Good afternoon, everybody. It's a great pleasure to give this talk about the present and the future of AI. And to start, I will say that to talk about the future of AI, we should agree on what is the purpose, the goal of AI, and there is a lot of confusion about that today. Let me say a few words about that. Today, there are two diverging opinions about the future, the ultimate goal of AI. Some people talk about artificial general intelligence. This is an ill-defined term. Artificial general intelligence focuses on building super intelligent agents by outperforming humans in the execution of particular tasks. They consider that the machine learning and its further development will allow us to achieve this goal. I have a different opinion. I consider that the goal of AI is building machines with human-level intelligence. Of course, we should agree on what it means, human-level intelligence. But if you open a dictionary, you have definitions of intelligence that are given before the advent of AI. It is the ability to learn, understand, and think in a logical way about the world, and the ability to do this well. And of course, machines can do impressive things today, but they cannot surpass humans in situation awareness, adaptation to changes, and creative thinking. I think also it's very important to agree on a concept of intelligence because we cannot develop a theory about intelligent systems without that. Now, my opinion is that AI is still in its infancy, despite all the impressive results we see. It only gives us elements to build intelligent systems, and it focuses mainly on assistance. While for future applications, we will require systems that continuously interact with environments with little or no human intervention. I consider that there are three different ways to use AI systems. We have assistants, like ChatGPT, for instance. You ask questions, you get answers. This is conversational AI we have today, but we will need the monitors. So the monitors will be streamers. We'll monitor what happens in a system, receive streams of events, and make predictions or allow experts to analyze what happens in the system. And of course, the ultimate goal is to have here AI agents that are controllers that dynamically interact with the system to achieve certain goals. We talk about autonomous AI. I think that the impact of AI on the real economy today remains limited compared to the enormous potential of AI applications. The AI industry revolution has only just begun, and its realization will depend largely on our ability to develop the AI-enabled agents and to build autonomous systems. So today, I think for AI, there are two important challenges. One is to build agents and autonomous systems, and the other is to have trustworthy AI. And this will be the topics of my talk, in fact. So autonomous systems stem from the need to replace human operators in complex organizations as envisioned by the Internet of Things. We talk about self-driving cars, smart grids, smart factories, and things like that. Autonomous systems are composed of agents. Each agent pursues its own goals, and the agents should coordinate also to achieve global goals, system goals. We talk about collective intelligence in that case. The agents also should be able to perceive and predict changes in their environment. So you can have very complex environments as for self-driving cars. And autonomous systems are the most difficult systems to build. They are highly complex. They are often critical. And I let you guess, we need a lot of things, a lot of properties that should be guaranteed. Another important issue, as I said, is to guarantee trustworthiness of AI systems, and we know that AI systems are reputed to be black boxes. So an important concern today is how to achieve safe AI. This has been the subject of a lot of discussions, even at international level. And of course, safe AI is very important if we want to control the risks induced by AI systems. Another important topic is apparently the satisfaction by AI systems of human-centric properties. And this is important to the extent AI systems try to mimic humans. And so big tech companies talk about responsible AI. We talk about alignment of AI with ethical, human ethical values. The problem is that for the moment we don't understand how human will emerges and how humans exactly make ethical decisions. So most of the work that is produced today lacks a foundation, and this is a big challenge, how to characterize the human-centric properties of AI systems. So this is an outline of my talk. I will discuss problems around the autonomous systems, the validation of AI systems, and talk about the future. Before I talk about autonomous systems, I would like to make an important clarification. We know that today we have two different computing paradigms. We have traditional computers that execute algorithms that can be understood and verified. And these systems deal with what we call model-based knowledge. And on the other hand, we have neural networks that can be trained to generate data-driven knowledge. But the problem is that we don't understand how neural networks work. And this is the important issue of explainability. Many people talk about explainable AI. I would like to give my point of view about that. What means explainability for a neural network? It means that we are able to characterize the input-output behavior of the network by a mathematical model. And this is theoretically possible, in fact, because we know the function computed by a node is the weighted sum of the inputs to which I apply an activation function. So this is theoretically possible. Practically, this is impossible for real-life neural networks. What's the consequence of this fact? That we cannot apply verification techniques and formal methods that we have used to get strong guarantees for traditional systems, and we can apply only statistical black box testing. Now, today there is a strong interest in AI agents. People think that this new year will be the year of AI agents. That there is a strong interest since, in fact, the advent of LLMs. And what does an AI agent? In fact, it interacts with an environment, it perceives changes of the world, of the environment, estimates the state of the environment, and predicts and plans actions to change the state of the world and satisfy a given goal. So today, you have some works that propose AI agents that can work by interacting with static digital worlds. So, for instance, you can have an AI agent who manages your email, for instance. But this is not sufficient to cover the needs for autonomous agents we have for many other applications. So there is a long way to go. An important trend is that we build agents around LLMs. And the idea is to augment LLMs with knowledge. So I would like to mention these two approaches, LLMs grounded to symbolic engines. But this is an approach I consider will be very, very important in the future to link LLM with long-term memory where we have stored knowledge. So this is the paradigm now. It's of retrieval augmented generation architecture. And I would like to explain the principle. So the idea is to build an agent that perceives the state of the external world. So typically, for instance, this can be the result of the analysis of images, and the LLM will not produce directly the word model, but will use a long-term memory. So, for instance, for a self-driving car, assume that you have a stop sign here. You have identified a source that you are in front of a stop sign. Then in the long-term memory, you may have rules that are applicable when you are facing a stop sign. and this will enrich the context that will allow the LLM to produce the best possible prediction of the world model. So this is the idea. There are today many different architectures for AI agents. So as you can see here, we compose different functions. And of course, the question is, what is a good architecture for AI agents? I'm not going to give details about that. And let me give my point of view about what is a reference architecture for AI agents. I am working on self-driving cars, so I'm taking this as an example that the proposed architecture is general enough. So what does an agent of self-driving car? We have the external world, the obvious interaction with by using sensors and actuators here. So you have to achieve situation awareness. For this, you need two functions: perception function that will analyze, say, frames, will identify obstacles, and then will use knowledge stored in this memory to build a predictive model of the world. So this will be an estimate of the state of the external world, based on which you will make decisions by combining two functions, the goal management function, and for each goal, you will have a planner that will generate commands sent to actuators. Now, it should be emphasized that for agents, you can have many different goals, possibly conflicting. For instance, for self-driving cars, you have short-term goals to keep the car on the trajectory, to avoid collision, or long-term goals. I'm driving to a destination. And this is a problem, how to manage all these goals. So you have the agent that exhibits this reactive behavior, this closed loop behavior. But I think for the future, this also knowledge generation, self-awareness will be something very important. So the idea is that you have an AI agent, an AI system here that monitors the state, updates the memory with new knowledge, and possibly issues new goals to be managed by this decision-making module. Of course, this is only a vision. The idea is that you combine a reactive and proactive behavior. So this is synchronous and this is asynchronous behavior. Of course, we don't know how to implement autonomous systems according to this principle. And why? Because we are facing different complexity limitations, complexity of perception. I hope you understand this. Complexity of uncertainty, because you can have dynamic changes in the system environment, complexity of decision also. This is, as I said, you can have many different goals. And if I cancel a goal, this change should be consistent with the other pursued goals. Now, building one agent is not enough. You have to integrate it, for instance, in an electromechanical system for self-driving cars. The agent should be able to harmoniously collaborate with human operators, and this is not just a human-machine interaction problem. And also, agents of a system should be able to adequately coordinate. So if I have, for instance, many self-driving cars, their coordination should not impede the achievement of goals of particular cars. And also synergy between agents is very important, because for self-driving cars, again, they should coordinate to avoid traffic problems. Probably you've seen the controversies around the deployment of robotaxis in San Francisco. You can have safe robotaxis, but they may be obstructing the traffic, blocking police cars. Now, where we are standing today in this, with respect to this vision of autonomous systems, if I consider that autonomy means situation awareness and decision making, so here I have increasing situation awareness for single domain and multi-domain, and here decision making for one agent and the system of agent, single goal, and many goals. I think that today we are here. We would love to get somewhere here, so to have systems of agents that are coordinated in an adequate manner. And this raises also problems that are independent of the fact that agents aren't agents. This raises systems engineering problem, for instance, how to achieve consensus between agents, distributed systems problem. So we are quite far from achieving this. Now, let me talk about validation of AI systems. First, I would like to talk about validation of technical systems like self-driving cars. I take the example of self-driving cars because this is characteristics of the problems we are facing today. But probably you know that there is a big discussion when a self-driving car is safe enough. Probably you've seen also this in the news. We've driven 10 billion autonomous miles, suggesting that their system is safe enough. It's clear that simulation is not enough because, and this argument is not in fact acceptable, technically tenable, just because they don't say how simulated mile is related to a real mile. And for this, we need some theory. When we have theories for testing hardware or software, and they rely on coverage criteria. And these coverage criteria are developed based on models of hardware and software. The problem is that for self-driving cars, we don't have models. We need so coverage criteria that explain that the simulation deals fairly with many different situations, and we don't have this today. So this is an open problem. But let me talk about another issue that will become also very, very important in the future, and this is the issue of alignment of AI systems with human values. The important question is the following. Can an agent be made credible in such a way that it gives the impression of human behavior, and what are the distinctive human features that machines have difficulty reproducing? So let me consider a concrete example. One can imagine that we can train LLM sufficiently well to pass final exams, final medical exams, and as successfully as students can do. And the question is, what does it mean that the LLM should be allowed to practice as a medical doctor? My answer is, of course, not, but we should understand why. And the reason is that the medical doctor acts ethically and rationally. And we have to prove that AI agents can act ethically and rationally. And this is an open question. Acting ethically or responsibly means that you see a medical doctor you can put a medical doctor in jail just because he did something very wrong, okay? And rationality also is an important issue. So I think that we should distinguish between behavioral properties of agents. Behavioral properties can be decided based on the external behavior of the agents, and cognitive properties that depend on the knowledge of the agents. So human-centric properties are cognitive properties, in fact. And here I'm distinguishing between risk-related properties and progress properties. So risk-related cognitive properties are normative. So this means that the agent conforms to ethical and law rules, legal rules. And then progress properties have to do with the way the agent chooses its goals and acts for their satisfaction. Unfortunately, I don't have enough time to explain all this in detail, but let me try to give you examples to show you what is the problem. What it means for an agent to act ethically. We suppose that an agent is equipped with a value system as a human mind is equipped. We have a value system to judge about, to make our choices. And this is a set of rules and a set of value scales to estimate the costs and benefits of our actions. So when we act ethically, we are aware of conflicting actions. We have conflicting actions. We have what we call an ethical dilemma, and we can assess the costs and benefits of these actions. For instance, okay, in some state of my mind, I am in a hurry to get to some place on time. So I may decide to obey red lights. So this can imply some delay. And then I can decide also to run a red light, okay, which is not a lawful act, okay? And of course, another example, if I have increasing production costs, I have signed a contract with a client, I breach the contract, or I provide the promised service, and I let you imagine that every time you have to find to take into account the cost and the benefits you have. So, unlike behavioral properties, ethical properties cannot be decided without also having some access to the agent's world knowledge. For instance, if I tell you the Earth is flat, is this a lie or this is an ignorance? And also, if I do something wrong, this is due to the fact that I am not aware I'm doing something wrong. In that case, I'm not responsible for that. Now, another important property of human mind is rationality, as I said, and being rational has various definitions. Is a concept that is considered in economy in particular. It means that you make optimal decisions or quasi-optimal decisions, and also that another property is that we reason based on competence level. So for a human, if I pass a test at a certain level, this implies passing a test at, be able to pass a test at lower level. So typically, for instance, if you pass a test for your driving license, you have a level of test that if you pass, we suppose that you can make it in more easy cases. And it happens that, in fact, AI agents are not rational. I have many examples that show that AI agents are not rational. Now, let me finish by talking about the future. Okay, what are the important issues in the future? I think that we should agree, at least as researchers, about a concept of intelligence, because this defines the ultimate goal of AI. In fact, autonomous systems show that intelligence is a multifaceted concept. In fact, there are multiple intelligences. To say that system 1 is smarter than system 2 is meaningless unless you specify the task and the criteria of success. So this is one thing. The other thing is that human intelligence is not a theoretical concept. It is the result of historical evolution in a given physical environment. So if we were born on another planet, perhaps we would have a different kind of intelligence. Now, if human intelligence is the target for AI should be able to perform and coordinate a set of tasks. So to show some broad evidence of intelligence, and we are not there. Today, we have, in fact, a big difference between human intelligence and machine intelligence. And there is some complementarity, in fact, between the two. So machine intelligence is able to deal with data, high-dimensional data, and the humans are able to reason symbolically, have the power of abstraction. So you can imagine that we can have some being that combines the two. Okay, will be super intelligent, but also this figure here suggests, raises some questions. For instance, can we bridge the gap between symbolic and concrete knowledge exclusively by using neural networks? Okay, which problems that humans can solve can be solved exclusively by using neural networks, because neural networks deal with database knowledge. Another very important issue is that AI will meet systems engineering, so traditional systems engineering, because we will have AI systems everywhere, in any device, in any appliance. So we will have to have design methodologies that build the trusted systems from untrusted AI components. We talk about hybrid architectures. And the deep problem here is how to link symbolic and non-symbolic knowledge, how to link sensory information and models used for decision making, typically for self-driving cars, sensory information from cameras and maps, for instance. How to move from concrete for correctness at design time to correctness at runtime. This is also a very, very important problem I don't have time to talk about. Then system validation. I said that we have a shift from rationalism to empiricism, and okay, so it's very, very important to now have some theory about how to test systems and achieve strong guarantees. We cannot achieve the strong guarantees we can have by applying verification techniques. So there are some possibilities to compensate this lack of guarantees by using knowledge. I don't have time to talk about that. Of course, also what is important, we have technical standards for the development of AI systems to estimate their trustworthiness. There is currently a blocking position from the United States that sees standards as an obstacle to innovation. And in fact, many AI artifacts are self-certified today. So typically, Tesla cars are self-certified, which means that you don't have an independent organism that guarantees that the car, the artifact is safe. Now, to summarize, there is a big gap between automation and autonomy. We have to work on that. If you have questions, we can discuss this. We need some new scientific and technical foundations. Now, this is my last slide. I think it's very important also for the acceptance of AI technology to reach some global regulatory framework that will define criteria of safety, trustworthiness of AI systems, and will allow us also to control the risks induced by the use of this technology. So everybody believes that we need such a framework. There's no agreement about what can be and should be regulated, what are the risks involved in using AI, how this can be achieved in practice. And just to give you an example, there is today a gap between the European Union and the United States when it comes to AI regulation. Probably you know that the European Union has today a very strong and complete set of AI regulations, with the AI Act in particular. And the key idea behind is that AI systems will be evaluated by using a risk management approach that is common to all artifacts, which means that we will require a high reliability for high criticality. If we apply these regulations, a lot of AI applications will not be accepted in the European Union at least. And on the other hand, we have US regulations that are more permissive. They include just recommendations to developers of AI systems. And also, I think that these are in line with positions of big tech companies that promote the principles of ethical AI, suggesting that AI systems should not be evaluated on the basis of strictly technical criteria. And okay, so the chances of reaching such an agreement today are really slim, and this should be also a concern. So I would like to stop here and thank you for your attention. Thank you very much. Thank you.
Thank you, Prof Sifakis. Now, let us invite Professor Liu Yang to moderate the session.
Good afternoon, everyone. So my name is Liu Yang from Nanyang Technological University. I'm really honored to be the moderator for this session, and particularly because I'm working on exactly the field like Professor Joseph Sifakis. Probably many of you may not know, Professor Sifakis is really the father of model checking, which is one of the important kind of formal method approach. And he made a profound contribution to this field and advanced computer science. And I just visited the Chinese Academy of Science and also the Southern University of Science and Technology. There are many collaborators, friends, and students of Professor Sifakis working there. So I think his impact is not just for the past contribution, but to keep going. And today we see he gave this wonderful lecture about this AI, where are we, and what are the possibilities in the future. I think this is also very aspiring and give us a lot of good insight about the importance and also the challenge of the trustworthy AI. Given this, I think we have lined up the questions, so let's probably go through one by one. Yes, we can start from this.
Actually, I'm from New Zealand, and now the microphone's working. I had a question in terms of the sort of models that have built AI and the fact that they have been built by humans who are inherently biased, whether it's subconscious or deliberate. So what's your opinion, and how do we deal with these models and the fact that the outputs are going to be inherently, therefore, built, like you're going to have that bias coming out again? So how do we deal with that sort of problem?
So what's the question exactly? How do we do with the...
How do we deal with the bias that comes out
with
of
the
the
bias?
models?
Oh, that's a very, very important question. Yes, yes. Okay, so let me try to explain now. Because the problem, there is an echo. Sorry, there is an echo. I have to. Yes. Okay, so let me try to talk about bias, because this is an important problem, and you have a lot of naive approaches to that. Okay, so you have papers that say that lack of bias, it means that we treat in the same manner. We don't distinguish between gender, or we don't distinguish between age and things like that. I mean, these are silly papers about that. You need to treat correctly the problem. You should consider what is the starting point, okay? What are the requirements exactly? So imagine that you want to build an AI system that will give scores to CVs of candidates for a position, for a post of nursing in a hospital, okay? So clearly women, objectively, I mean, they are better than men here, okay? So you will start by an analysis of data that comes from human experts, and then you want to train your system to distinguish in the right manner the qualifications of humans and men. And to do this, you need to have a theory, and we don't have a theory. And the theory should be based on statistics. So I will start from the raw data, and then I will define my training set, and my training set should have the same statistics, statistical characteristics as raw data. This is a very hard problem. So the training set should reflect the differences also in the choice between human and between male and female candidates. Okay, and non-bias here does not mean that you treat equally for equal qualifications men and women. So that's a problem that I don't know how to treat in a rigorous manner. Okay. I don't want to give more details about that. This is a hard problem, okay? The problem is, in fact, that we don't have a development methodology where we can track and test. We have steps. You see, in traditional systems engineering, I have worked a lot with that. You start from requirements. And then at each step of the development of the system, you check that you are doing something that is consistent with the requirements. Here, we don't have anything. Of course, you have some empirical approach, and the humans can judge about how faithful you are to the requirements, but you don't have any objective criteria. And this is a problem, in fact.
Thank you.
Sorry, I can be longer, but perhaps there are other questions.
Okay, maybe next one. Yeah.
Good afternoon, Professor. So just want to say thank you so much for your insightful discussion. And my name is Adolphus Lai, and I'm from the Singapore Nuclear Research and Safety Institute. And essentially, I have one short question. I just would like to comment that recently, the concept of physics-informed machine learning has gained traction in structural engineering, nuclear engineering, and risk analysis. And we're referring specifically to the use of physics-informed neural networks as the explainable AI. I just would like to hear from you, and because it's not really covered in today's lecture, just want to hear from you, like, what do you think is the potential of physics-informed neural networks as the solution to providing explainable AIs?
Well, I don't think that we can. I don't think we can explain AI. I mean, there is some, and this is not a theoretical impossibility. In fact, okay, there is no theoretical impossibility. But it's a practical impossibility. because AI uses neural networks. So you see, when I analyze, I verify that the program is correct. When I verify that a piece of hardware is correct. So a piece of hardware, a program is an artifact. I extract a model, a mathematical model, I reason in that, okay? Now, there is a source of confusion, of course, that they talk models, the artifacts. They talk models, the neural network. I mean, there's a huge confusion about that. Neural networks are not models, they are artifacts. The problem is how to extract a model. Now, all the papers about explainable AI have some weak definitions of what is explainable. So, for instance, they say, I can explain the causal relationship between this input and this output, okay, things like that. I respect this work, and I think this is interesting work, but this does not allow to guarantee safety, because to guarantee safety, you should know the whole behavior. You should reason in terms of possible situations, possible states. So for me, explainable AI is a completely lost cause. I mean, we cannot achieve that. We have to live with that. And another reason we cannot achieve explainable AI is that you don't have also objective criteria. Because you have non-technical systems. Okay, consider, for instance, ChatGPT. The input is natural language, the output is natural language. What kind of theory you can develop about that? Okay, so we should be serious. And it's a pity that you have plenty of people working on safe AI and claiming that they can achieve safe AI by applying formal methods. I mean, this is not possible at all. And then this is, perhaps they get some money to do that, but this is not reasonable. Okay, thank you.
Thank you so much, Professor.
Yeah, next one.
Right. Thank you, Professor, for your sharing. I'm Gary, and I work on AI for wireless comm systems. And my question is with regards to looking at the AI research scene these days. Things are becoming prohibitively expensive to be able to do impactful AI research, and it's kind of dominated by a lot of industries. And I was just wondering if we could get some advice on how maybe academic groups or smaller groups who might not have access to such resources can still contribute, especially towards the agentic kind of research.
Okay, thank you. Thank you for the question. This is a good question. So let me comment on this. There is this trend to gigantic AI. And also there are people who say that, you see, for agents, there is an important discussion in the community, how we can build agents. It's clear that database knowledge is not enough. So at some point, everybody agrees, even the pool, for instance, that we would need some capabilities of reasoning. Now, some people say, oh, to achieve capabilities of reasoning, this will be an emerging property. So if we have systems with trillions of parameters, perhaps they will be able to reason. Okay? And this, I don't agree with this point of view. I don't have time to argue, but now, even when we have impressive results, for instance, with O3 or some other systems, you see that they are using a model-based approach and some reasoning. Also, AlphaGo 0, okay, they have used some modeling. I mean, they build some models by using Monte Carlo techniques. So I think that we should combine data-based and model-based. But of course, this trend to gigantism is also is a political game, because big tech companies can spend money and they are pushing in that direction. And this, of course, makes academic research or small countries too dependent on these players. So that's a pity. I think we should be more smart and try to combine to have smaller AI systems that rely on. So I have discussed, I believe the right solution is to use LLMs of moderate complexity and to connect them to memories. The problem, of course, is how to make these RAG architectures effective. And here, so in the memory, you should have, of course, knowledge stored. You can imagine that we have even symbolic knowledge stored here. The problem is how you access we find for a given query all the relative knowledge to get the most general context, and there are approaches for that. How to store knowledge in a memory. You can use semantic graphs, you can use vectors, and then you need some similarity relation. All these are open problems. There is a large debate about how to solve this problem. This is the challenge for me. In fact, the challenge is how to connect knowledge to AI systems. This is a big challenge. Thank you.
Thank you.
Maybe I can just add a little bit. So we are facing the same problem. Actually, what we are doing is that we're trying to leverage the basic knowledge of the basic capability of large language model. Well, the focus is not to enhance that, but rather than precisely extract the useful knowledge and apply the knowledge into on top of the large language model, which is the vertical to this capability of models.
Yes.
That is, I think, the key we should focus on, which is actually quite difficult to have an effective way to extract useful knowledge and apply that knowledge. Yeah. Yeah,
Yes.
next one.
Okay.
Hi, Prof Sifakis. My grandfather's name is Kupakis, so I think we are both from Crete. My question is to do a little bit with the global reliability framework that you talked about, specifically with regards to ethics, and the example I'm going to use is self-driving cars again. We have to program some amount of ethical value into a self-driving car, for example. Say in the event of a crash, does it take a utilitarian solution that tries to minimize loss of life and casualty, or does it prioritize the life of the driver, for example? In a global reliability framework context, do you think we have to worry about programming in a type of, say, like cultural relative or cultural relativism in ethics when we try and standardize it with some sort of global reliability framework, if that makes sense?
Okay. Thank you for the question. Okay. So I think this issue of ethics is a very important one. But we should distinguish between the technical, we should understand what it means to act ethically, okay? And there is a lot of confusion about that. Now, regarding the example of the self-driving car, there are so many problems to solve, okay? Technical problems. The issue of ethical choice that is often mentioned in papers, this is a completely marginal problem with respect to the problems we are facing. So I will say that let's prioritize, let's set priorities, okay? So in particular for self-driving cars, I work on testing self-driving cars. What I find with existing open source autopilots is horrible, okay? They are too bad, they are very bad. Of course, the problem here is that accidents are rare situations, are rare events. So it's very hard to reproduce exactly in simulation environments. And there is a lot to say about that. But I will say ethics, first of all, we should understand what it means for a system to act ethically. And this is an open problem, at least for me, okay? Because this means that you equip the system with a value system, as our mind uses a value system, okay? And you have value scales. So when you decide, you make a whole analysis. That is should be rational also. Also, I have doubts about the rationality of AI systems. I mentioned this example, okay? I have AI systems that drive self-driving cars. They manage it very well in a difficult situation. In a less difficult situation, they mess it up. So I would say there are a lot of problems to solve, should prioritize. Ethical behavior of AI systems will be an issue, but first of all, we should be careful to understand what it means to act ethically. All the papers I have analyzed in the literature have important flaws. One flaw is in particular that they don't distinguish between human responsibility and the manufacturer's responsibility. So they treat this, and it's very simple. If I have a system, you can say, this is a technical problem. And so, if, for instance, the fact that ChatGPT can generate fake news, okay, this is a safety issue, okay? It's not an ethical issue. It's a technical generate, so this should be excluded by design, okay? Now, if I distribute fake news, it's my responsibility, and this should be penalized. This should be treated by a legal framework. So there is a lot of confusion also in this discussion about the ethics of AI, and that should be clarified.
Yeah.
And of course, just to finish, I'm talking a lot, but just to finish, I will say that this idea that of ethical AI is used also by some big tech companies to suggest that we don't make a technical evaluation of AI systems, and they should be treated so that the debate about their safety becomes purely subjective. And this is too bad. Okay, thank you.
Thank you. Thank you, everyone. I think the time is up. Sorry, I think we're running out of time. I think today we really have this chance to listen to this wonderful lecture, which is talking about very important things about AI. Particularly, I think in the second part, when we talk about this, I think Professor Sifakis mentioned is cognitive property, which I think are the very important thing where the traditional software engineering and the software development never think about. When we talk about traditional software, we think about functional correctness, non-functional correctness. But when we talk about the agent, robot, we need to think about how we deal with humans, which are completely different things will come out, like the morality, ethics, even whether the agent is humorous, because these are the important things later we want to leverage the agent to do. And when you particularly write, even nowadays, when you write prompts, you want to set up the certain roles. This is an extrovert kind of person. This is a lawyer. This is a particular kind of person and particular gender. Whether the large language model can understand this and behave accordingly, this is a very important thing. And we hope the agent can work under the constraint and morality so that we have the control of the agent. I think this is a very important direction for the research. The last part about the possible intelligence, I think this is open up a lot of doors, which really showed us the AI is in the early stage, how to understand the symbolic power of the human reasoning capabilities and integrate that into the agent and the AI. I think this is still a long way to go. But all of this, I'm fully convinced that the topics are very important. And over the lunch, one of my postdocs told me he took the Professor Sifakis' course in EPFL, and he told me Professor is what a wonderful lecturer, and he got the full mark for the assignment. And today I'm fully convinced that not by the assignment, but really by the presentation and the Q&A he gave in the lecture. And let's thank Professor Sifakis once again and give him one round of big applause. Thank you, Professor.
Thank you very much. Thank you very much.